Hello, Math 2. This is Unit 8, Lesson 2, and this is Part B, where we are going to look at how the quadratic formula relates to graphs. So we can find the x-intercepts of the graph of the function f of x equals x squared plus 5x minus 14 by finding solutions to the related equation x squared plus 5x minus 14 equals 0. In other words, we can factor to find the x-intercept. So if I'm factoring x squared plus 5x minus 14, my factors are both going to start with an x. And I'm thinking about the number 14, 1 times 14, 2 times 7, and I'm thinking of a combo that can help me have a middle term of 5x. So I think we need a positive 7 and a negative 2 in our factors. So the x-intercepts correspond with those two factors. So if I have a factor of x plus 7, I have an x-intercept at negative 7. And if I have a factor of x minus 2, I have an x-intercept of positive 2. So on my graph, these x-intercepts are occurring at negative 7 and positive 2. Now, the original function in standard form shows me the value of the y-intercept. So this function has a y-intercept of negative 14. So if our quadratic is factorable, we can use the factors to find the location of the x-intercepts. But not all functions are factorable. So this function, g of x, x squared plus 5x minus 10, we can't factor that. But we can use the related equation x squared plus 5x minus 10 equals 0 to find the x-intercepts, or the zeros of the function. So let's use the quadratic formula here since it is not factorable. So our a value is 1, our b value is 5, and our c value is negative 10. So in the quadratic formula, it's negative b, whoops, I mean to write the numbers in, sorry, negative 5 plus or minus the square root. I need my b value squared minus 4 times a times c, and that's all divided by 2a. So if we simplify this a little bit, let's figure out what number is under our radical. So we've got 5 squared minus 4 times 1 times 10. Sorry, that's a negative 10. So that's 65 under the root. Now, if I check the radical root 65, that one does not simplify. So this would be our two solutions to that equation. So on the graph, this actually does give us those two x-intercept values. Let's figure out what they are rounded to the nearest hundredth. So negative 5 plus root 65 over 2 gives us one of them. So you could type that into your calculator. Just be really careful. Use the use the fraction button first and put the numerator in, and then put the 2 in the denominator. And this is the plus root 65 one. Now, when you type that in, if you have the TI-30, the calculator will just kind of spit that back out at you, and you need to use the converting approximation button to get the decimal, and this is about 1.53. So we can see on the graph that is at 1.53. The other root, or the other zero, is at negative 5 minus root 65 over 2. So again, use the fraction button first. Type in the numerator, put the 2 in the denominator, and get the decimal value of that, and it's negative 6.53. So that's how we are able to find our two x-intercepts. And then our y-intercept, of course, we can get from the original standard form equation. It's negative 10. So there's a sketch. So these types of roots that are coming from these radical forms, they're called irrational roots or irrational zeros. of the function. Here's those two functions graphed together. Kind of interesting to see them together. So the one we factored had roots at 2 and -7, and then this one had those irrational roots. Just kind of interesting that these are just shifted up. That second function is just shifted up 4 from the blue function. So it's kind of interesting to look at. And that's just because the only difference between these two functions is -4. All right, so if we have an object, so a lot of problems are able to be modeled and solved using quadratics. So in this case, we have an object being thrown into the air with an initial velocity of 5 meters per second from a height of 9 meters. So I'm going to put a 9 right there. The equation h of t is equal to -4.9 t squared plus 5t plus 9 models the height of the object in meters after t seconds. About how many seconds does it take for the object to hit the ground? So in this case, this moment that it's being thrown, that's like t equals 0, and it starts at a height of 9. And then we've got this parabola modeling how long that ball is in the air, and we are looking for what time does the ball hit the ground. We have the equation for this. We have h of t is equal to -4.9 t squared plus 5t plus 9. And we want to solve for t and know when that ball is going to hit the ground. Well, hitting the ground is at a height of 0. So we're going to put 0 in for the height. 0 equals -4.9 t squared plus 5t plus 9. And we've got a decimal coefficient here, so we definitely don't want to try to factor this. So we're going to use the quadratic formula to find our answer. So our a value here is -4.9. Our b value is +5, and our c value is +9. So I should use t. Our variable here is t instead of x. If you accidentally switch to x, it's really not the end of the world. Even in calculus, they forgive that if you do that accidentally. So it's the opposite of b, plus or minus the square root of b squared minus 4 times our a value of -4.9 times our c value, all divided by 2 times our a value. Now, in this case, if you want to try to type this whole thing into your calculator, obviously you can't type in the plus or minus symbol, but if you want to try to type in the expression as is in your calculator, you can. I still personally prefer to simplify my radical. So we've got 5 squared, or at least get that inside number, 5 squared minus 4 times -4.9 times 9 is 201.4. And on the bottom, 2 times -4.9 is -9.8. So now I'm going to split that into my two answers. T equals -5 plus root 201.4 all over -9.8, and t equals -5 minus root 201.4 over -9.8. And I'm going to put that, you can't put the plus or minus symbol in your calculator. You just have to evaluate each of them separately. Use your fraction bar first. -9.8 on the bottom. So this first one gives you an answer that is approximately -0.94. And now I'm going to put the other one in my calculator to get the other answer. 201.4 over -9.8. The other answer would be at 1.96. And time in this question is in seconds. So the first solution is actually what we would maybe call an extraneous solution, because it's talking about this time right here. Like if we extended that parabola, it would have this negative root over here. We're really looking for the positive root, or the positive zero of that equation. And that's our true answer here that we're looking for, 1.96 seconds. So the context tells us that we're going to ignore that first answer and just keep that second answer as our answer. So it should take about 2 seconds to hit the ground, a little bit less than 2 seconds. All right, so there's some practice problems in your packet, or some Edulastic. Talk to your teacher about what your assignment is. Thank you so much.